Hello everyone, I'm Shravya from Sri Venkateshwara College of Engineering. In this video, I'm going to discuss about corrosion in chemistry. In that we have introduction, basic types and types of corrosion and corrosion control methods. Let us know some introduction about corrosion. Examples are, first of all, what is corrosion? Corrosion has been defined as a destructive chemical and electrochemical reaction of a metal with its environment like oxygen, moisture, and carbon dioxide, etc., which disfigures metallic products leading to reduction in their thickness and also causes loss of useful properties such as malleability, ductility, electrical conductivity, and optical refractivity. Examples: rusting of iron due to formation of hydrated ferric oxide, tarnishing of silverwares in H2S laden air due to formation of silver sulfide. Next, we have some examples of corrosion. We can see in these pictures. And next is basic types of corrosion. That is dry corrosion and wet corrosion. Here we have the dry corrosion, that is mean chemical corrosion. In that, it involves the direct attack of chemicals on the metal surface. Corrosion occurs in the absence of moisture. The process is low and the process of corrosion is uniform. And the example is formation of AgCl on silver metal. Now we have wet corrosion, that is mean electrochemical corrosion. In that it involves the formation of electrochemical shells and it occurs in the presence of conducting medium. It is a rapid process and it depends on the size of the anodic part of metal. And the example is rusting of iron. And we have the types of corrosion. In that we have two types: differential metal corrosion and differential aeration corrosion. In that, now differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode. It undergoes oxidation and gets corroded. And the other metal with higher electrode potential acts as cathode. It undergoes reduction and protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. And differential metal corrosion. At anode, M is to Mn plus electron. At cathode, reduction reaction takes place depending upon the nature of the environment. Example, first one is tin coating copper vessel. Second is steel pipe connected to copper plumbing and bolt and nut made of different metals. And fourth one is when iron is in contact with copper 0.34 volt and iron is minus 0.44 volt. It becomes anodic and undergoes corrosion, whereas copper becomes cathodic and remains unaffected. Now, differential aeration corrosion. When a metal is exposed to different concentration of air oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion, where other part of the metal exposed to higher concentration of oxygen, it becomes cathodic and it remains unaffected. This kind of corrosion is called as differential aeration corrosion. In that we have the examples: iron rod partially immersed in NaCl solution. Part of the metal immersed in solution is exposed to lower concentration of oxygen. It becomes anodic and undergoes corrosion, whereas part of the metal outside NaCl solution is exposed to more oxygen, becomes cathodic and remains unaffected. And the anodic and cathodic reactions are: at anode, Fe is equals to Fe2 plus 2 electrons. At cathode, 2H2O plus oxygen plus 4 electron is gives rise to 4 hydroxide. And iron plus hydroxide is gives rise to FeOH. Here we have the example of aerational corrosion. And next, waterline corrosion. It observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, The inner portion of the tank below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Here, thus the portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and it is unaffected. A distinct brown line is formed just below the waterline due to the deposition of rust. The shell reactions are: at cathode, M is gives rise to Mn plus Ne. At cathode, 2H2O plus O2 plus 4 electrons gives rise to 4 hydroxide. And finally, the ions combine to form corrosion product. Here we have the example. And pitting corrosion here. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. In pitting corrosion is due to metal surface is not homogeneous and external environment is not homogeneous. Crystallography directions are not equal in the reactivity. Environments are not uniform with respect to concentration. When pitting corrosion results when the portion of the metal covered by dust which is less aerated becomes anodic and undergoes corrosion and form pit. The remaining area of the metal which is exposed to higher concentration of oxygen becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because formation of small anodic area, that is pit, to corrode faster because accepting electrons from the cathodic area increases. At anode, Fe gives rise to Fe2 plus 2 electrons. At cathode of oxygen plus water plus 2 electrons is gives rise to hydroxide. And the net reaction is Fe2 plus 2 OH is gives rise to FeOH twice. Here we have the diagram of pitting corrosion. And now corrosion control methods. In that, corrosion can be controlled by preventing the formation of galvanic cells on the surface of metal. Here we have two types: design and selection of materials and protective coating. In protective coating, we have two types: inorganic coatings and metal coating. In metal coating, we have two types: anodic coating and cathodic coating. And third one is cathodic protection. In that, we have two types: sacrificial anode method, impressed current and voltage method. And next we have the protective coating. In this method, the metal surface is isolated from the corrosive environment by protective coating. In that metal coating, the process of coating base metal with a layer of protective metal, and anodic coating is, in this coating, the metal is anodic to the base metal. The example of anodic coating is galvanization. And the process of galvanization means the metal surface is washed with organic solvent, that is CCl4 and toluene, to remove organic matters. The metal surface is treated with dilute H2SO4 to remove rust and other deposits. Then it is well washed with water and it is air dried by passing with hot water. And the galvanization means the process of coating steel or iron with a layer of zinc to protect against corrosion. The metal is treated with ZnCl2 and NH4Cl solution, which prevents the oxidation of coated metal. Then the metal is dipped in molten zinc at 450 degrees Celsius. Here we have the diagram of that. When it comes to iron sheet, in that cathodic protection, it is the technique of offering protection to a specimen against corrosion by providing electrons from an external source. In that, first is sacrificial anode method. It is the method where it involves the use of metal which is anodic to the specimen. In this method, the metallic structure to be protected is connected to a more anodic metal using a metallic wire. And the commonly used sacrificial anode are magnesium, aluminium, zinc, and their alloys. Example, protection of ship's hull by fixing zinc plates, protection of an underground pipeline with a magnesium anode. And we have impressed current method. In this method, the electrons are supplied from a source of a direct current, that is battery. Here we have the diagram of that impressed current method. The advantages of impressed current methods are quite low installation cost and minimum maintenance cost for after installation. It is used for protecting water storage tanks and oil pipelines. Thank you.